All right, so we're going to practice optimization, kind of getting ready for simple problems on the multiple choice of the AP or optimization problem probably on your final. And this is one of the maybe simpler ones you would get. Find the point on the line, 3x plus 2y equals 12, closest to the point, negative 1, 3. And to get us started, we don't need a picture, but sometimes it sure helps. So I made a little picture for us to use and reference. Then I made point, negative 1, 3, letter A, and I made this line L, the blue line then. Everybody, we're going to make an optimization problem. We are going to minimize the distance from A to line L. And that, we know it's going to be perpendicular from our days in pre-calc. But to do this, I'm not going to draw it as a perpendicular line. I'm actually going to draw it at an angle and say it just goes to some point xy on the line. All right? It goes from point negative 1, 3, point A, to some xy on the line. And I can make the distance equation for this. Everybody, when I make the distance equation, especially in calculus, I do not want to do the square root. So I do it as Pythagorean theorem. I picture it being over here, some xy. And this is the distance d between the points, right? And it's x minus a minus 1, so x plus 1. 3 minus y, or I'm going to write it as y minus 3, all right, as the distances. And I can say right away, I can develop this equation. Hey, I know d squared is equal to the quantity x plus 1 squared plus the quantity y minus 3 squared, our distance equation. And now I can use my noggin and say, hey, I want to minimize this blue distance d. You know, I want to minimize that distance. But if that number is small, if I'm minimizing d, can't I minimize d squared? And I can save myself taking the square root. Now I'm going to say, okay, let's call little d capital D. And I want to optimize that. I want that to be as small as possible. All right, that equation, d equals x plus 1 plus squared plus y minus 3 quantity squared. Big problem for optimization. It has two variables. We have to get to 1. But what do we know about our point? It lies on the line y equals negative 3 halves x plus 6. So I'm going to replace y with negative 3 halves x plus 6. So d equals x plus 1 squared plus negative 3 halves x plus 6 minus 3 quantity squared. I'll do a little cleanup here. And all of a sudden now, I have an equation that that has one variable. And everybody, I can take the derivative of this. And I'll do it with the chain rule. I can find d prime is equal to, take the derivative, 2 times x plus 1. Derivative of the inside is 1. I'll write it here so we even remember we're doing it. Plus 2 times, derivative of the inside stays the same, times the derivative of the inside, which is negative 3 halves. All right, I got a little cleanup here, and I'm going to take the time to do it here. D prime equals 2x plus 2 for the first distributing. Over here, I can cancel the 2 and the 2, and I distribute the negative 3 plus 9 halves x minus 9. All right, I combine like terms, right? That becomes 4 over halves, I think. That's 13 halves x minus 7 equals d prime. Right? Everybody, what do I want d prime to be? If I want to optimize, I want set it equal to 0. So d prime equals 0. So 13 halves x minus 7 equals 0. Guess what? Bring the 7 to the right side. 13 halves of x equals 7. I think x equals 14 thirteenths. Can you imagine doing this with substitution or elimination? Did I make a math mistake? That's a 2. It's not an 8.
Okay,
I tell you what, I'll do that. Yeah, I see what you're saying. I canceled the 2 here. Sorry, that's 2. That got canceled. So everybody, it's 14 thirteenths. I just found the x coordinate of the point closest to the line. How do you find the y point? You plug it into that ugly equation. So if I go the entire page, and it's long, okay? If I want to find the y coordinate, I just use my calculator. I got negative 3/2 x minus plus 6, right? And I get icky. I get y equals negative 42 over 26 plus 6. This is definitely where I want to get a calculator because I don't want to make a math mistake if I haven't already. Pretty sure I haven't. I get 57/13 for y. And everybody, I just found the point. It's 14/13, comma, 57/13. And we just optimized the distance between a point and a line. All right? The big thing I'm looking for is getting down to one variable and the understanding that you're setting it equal to 0. Distance between point and the line. All right. Keep practicing. Don't surrender. Guys,